This is Geometry Unit 4, Lesson 3 on translations. A translation is the third kind of transformation that we're going to be talking about this year. The first kind, remember, was a line reflection, where you're folding an image over a line and it comes out to be a mirror image. A rotation, remember, is a turn, either clockwise or counterclockwise. A translation is a slide. So you are going to be moving every point the same distance in the same direction. Now, each point of the figure will move a given distance horizontally and a given distance vertically. So when you are sliding something, you are actually going a horizontal distance and a vertical distance. So let's take a look at point B for a second. All right, let me look at point B, and I'll do it as a dotted line so you see where I'm going. To get from B to B prime, I would have to go horizontally this far, and then vertically this far. Pretend that's vertical. There we go. To get to B prime. Notice that makes a right angle. This is the horizontal. This is the vertical. So, to go from B prime, I have created what's called a vector. A vector is a description of going from horizontal and vertical distance. So your vector here is from B to B prime. The distance from B to B prime is a vector. So the vector is the distance and direction moved. It's distance and direction moved, so it's a vector. So B prime is a vector. Now, when you see a vector, sometimes it's written like this. That means vector. So you could say B prime is the vector there. Now notice, since this is the horizontal and the vertical distance, the vector is actually the hypotenuse of a right triangle. So the distance can be found by using Pythagorean theorem. We can find the distance from B to B prime. Now there are all kinds of vectors you can draw. You can connect any points with vectors. So if I want to go from C to C prime, I would go the same vector distance from B to B prime. So let me do it in a different color so you can see what I'm doing. If I went for C, I went this far to the left or to the right and this far up. So I'm going to do the same thing for C. I'm going to go that far and then up, same distance. So my vector from C to C prime would be right here. And it should be the same length as B to B prime. So there's your vector right there. All right, and then A to A prime, same idea. You're going to move the same distance as you move for B in the same direction. So from A, I move that far horizontal and then that far vertical. I end up at A prime. So my vector from A to A prime should be the same as B to B prime. So all of these points move the same distance in the same direction. That is a translation. Now let's look at some of the properties of translations. What's special about a translation? For any 2 points P and Q and their images P prime and Q prime. So basically what this is saying, when I go from P to P prime and Q to Q prime and create a segment, which would be the vector, so for example B to B prime would be the vector here. What's happening, the distance from P to P prime and Q to Q prime should be the same, so they are congruent. If I look at the vectors I created here, B to B prime is congruent to C prime, is congruent to A prime. So all of these vectors, the red one, the blue one, the green one, are all congruent. They're all the same length. Now, not only are they also the same length, they are also parallel to each other. If we look at our vectors here, A, C, and B, since they moved all in the same direction, they will also be parallel. B prime is parallel to C prime, is parallel to A prime. Since they move in all the same direction, the same way, all those vector lines are going to be parallel. Now, also with translations, as with line reflections and rotations, what you start with is what you end with. Distances are preserved. If we look at the triangle we started with, this triangle here, ABC, A prime, B prime, C prime is exactly the same triangle. So AB, the length of the segment, will equal A prime, B prime. BC, will be congruent to B prime C prime, and CA will be congruent to C prime A prime. All the lengths of the segments stay the same. And all the angle measures are preserved. Angle A will be congruent to angle A prime, angle B will be congruent to angle B prime, and angle C is congruent to angle C prime. So the size stays the same, and the angle measures stay the same. So all distances and angles are preserved. What you start with is what you end with. All right, now let's see how translations work on the coordinate plane. We have our triangle ABC here with vertices at A 50, B 24, and C negative 1, 2. They're already graphed over here. A certain translation moves A to A prime, and draw A prime, B prime, C prime under that translation. Basically, what they're asking you to do is how did you go from A to A prime horizontally and vertically? All right, let's look at horizontally. To go horizontally, to get from A to A prime, we had to go 1, 2, 3, 4, 5, 6 to the right, 1, 2, 3 down. All right, so our rule here is going to be going 6 to the right and 3 down. So A prime, 6 to the right and 3 down, ends up at the point 11, negative 3. If I count over there, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 1, 2, 3. A prime ends up at 11, negative 3. So I'm going to apply that same rule to each one of these points. So at B, 6 to the right, 1, 2, 3, 4, 5, 6, and 3 down. 1, 2, 3. So B prime will end up at 1, 2, 3, 4, 5, 6, 7, 8, 1. And then C prime starts at negative 1, 2, 6 to the right, 1, 2, 3, 4, 5, 6, 3 down, 1, 2, 3. C prime ends up here, and that is at 1, 2, 3, 4, 5, negative 1. And if I draw my triangle in A prime, B prime, C prime, I have moved every single point exactly the same way, horizontally and vertically. And you can see that my triangle has slid 6 to the right and 3 down to end up where I am. Okay, now, the rule for this translation, we are describing what happened to each of the coordinates. If we are moving 6 to the right, what coordinate are we affecting? We're affecting the x-coordinate. So if we're starting at xy, moving 6 to the right, if you're going to the right, that's in a positive direction. So that would be x plus 6. And then the y moved 3 down, because down is up and down is the y-coordinate, so it would be y minus 3. So this rule, if we apply it to the coordinate here, for example, 5, 0, 11, negative 3, that would be 5 plus 6, negative 3 minus 3. Or, excuse me, 0 minus 3, sorry, wrong point. All right, so there's the original, added 6 to it. Here's the original, minus 3 to it, and you end up at 11, negative 3. So 2 to 8, added 6. 4 minus 3 is 1. Negative 1 plus 6 is 5. 2 minus 3 is negative 1. So that's the rule. So, the notation for a translation. Translation you usually see with a capital T and then these lowercase a and b here. The A is telling you how x moves, and B is telling you how y moves. And you always add the coordinates. So T of AB of x point xy means to take the point x, add A to it, and then take the point y and add B to it. So if we used the notation of TAB for this one we just did, this would be T 6 negative 3 of xy. That would be my translation, because that is x plus 6, y minus 3. And that's exactly what we're doing. So this is the plus 6, this is the minus 3, 6 to the right, 3 down. That's the x, that's the y. Now let's see if we can figure out what this point is going to end up at. We have t of negative 5, 2 of 4, 1. So our point that we're starting out with is 4, 1. 1, 2, 3, 4, 1. Let's see if we can figure out what the rule is. T negative 5, 2. All right, the negative 5 means that you're going to take the x and add negative 5 or subtract 5 from it. And then the y will be y plus 2. So that's what that rule means. So if I take this point, I want to go 5 to the left because it's minus 5, And then plus 2 means we're going to go 2 up. So let's see what algebraically and graphically where we end up. So 4 minus 5, 2, or it's going to be 1 plus 2. And where do I end up? 4 minus 5 is negative 1, 1 plus 2 is 3. Let's see if that's right. 5 to the right, 1, 2, 3, 4, 5, and up 2. 1, 2 puts me right there, and that's the point, negative 1, 3. So t translation of negative 5, 2 of the point 4, 1 ends up at negative 1, 3. Let's look at one with vector notation. Consider the transformation t of tj vector. What does tj vector mean? That means that the image of t is j, because you start at your vector t and you end up at j. So the image of t is j. So each point moves the same way from t to j, from t to j. T to j, sorry. Okay, so how are we moving from t to j on this grid right here? Well, here's t right here. And we want to move from t to j horizontally and vertically. So t is here, j is here. How did we move horizontally? We would have to go 2 to the left, and then up 1. So 1, 2, 1. So do the horizontal, then do the vertical. All right, so using that translation, 2 to the left and up 1, what is the image of w? So we start at w, 2 to the left, 1, 2, and up 1. You end up at m. And that is the image of w. Now, what is the image of ks? If you start with a segment, you should end with a segment. So do each individual point, and then that'll be your segment. All right, so if we take k, 2 to the left and 1 up, here's k, 1, 2, and up 1, I end up at c. And if I take s, 1, 2, and up 1, I end up at I. So that is a line segment. So ks becomes ci, 2 to the left, up 1, and that's my new segment. All right, the pre-image of hi. Well, hi is right here. Here's hi. So if this was this is saying we've already done the translation 2 to the left and up 1. If I wanted to know what was it before, what would I have to do? Well, I'd have to take I, instead of going 2 to the left, I would have to go 2 to the right, and then instead of up 1, we'd have to go down 1. That would be backwards. All right, so let's take h. 2 to the right, 1, 2 puts me at j, and then down 1 would put me at q. And then 2 to the right, 1, 2, and then down 1 would put me at s. So the pre-image of hi is qs. So we ended up here. Now is qs, if you move from qs back to hi, it would go 1, 2, and up 1, and you're back where you started with. All right, so what is the symbolic notation for this translation? If we use the t, we went 2 to the left, so that would be minus 2, and up 1 would be 1. So t of negative 2, 1. Now, using this same chart above, let's see if we can interpret the different kinds of notations that we have here. We have r of j of c. All right, what does capital R means? So this is a rotation around j. Now, if it's just the letter j, how many degrees is that? It would be 180 degrees. So here is j, it's going to be my center of rotation. I'm going to take c and go 180 degrees around c. All right, 180 degrees around c, or it's going to be around j of c. So I'm going to take c and go 180 degrees. I end up at s. All right, now what does the lowercase r mean? That means a reflection in or over CW. All right, so we are going to reflect over CW. So CW is this line right here. Now, how do you do a reflection? Well, here's M right here. Remember, it's perpendicular to the line of reflection, same distance on the opposite side.